So here is question number 16, everyone. The displacement of two identical particles executing SHM varies with time t as y1 equals 3 sine 8t plus pi by 6 and y2 equals 3 by 2 cos omega t. The value of omega for which the total energy of both particles will be same. Total energy given by the expression half m omega square amplitude square. So according to question, E1 equals E2. Therefore we can write half mass same because the particles are identical. Omega 1 square A1 square equals half m omega 2 square A2 square. Putting the values, half m cancel out. Omega 1, that is 8. So 8 square into A1 3 square equals omega 2, that is omega square, into A2, that is 3 by 2. So 3 square by 4. 3 square cancel out. We will get the value of omega as under root 8 square into 4, that is 16 units. So we will go with option number 1 only, which is absolutely correct. Now move on to the next, that is 17 number. So here is question number 17, everyone. An object of mass m is placed at a distance Re upon 2 from the center of Earth, where Re is radius of Earth, we all know it. The gravitational potential energy of the object will be what at that point? See, this is the Earth, suppose, center. Here we have to calculate the gravitational potential energy. Suppose the gravitational potential at this point is V, then the gravitational potential energy will be what? M into V. M is mass of object, V is potential at that point. So finally we have to calculate the gravitational potential of that point, which is given by the equation V equals minus GME upon 2RE cube within bracket 3RE square minus R square, where small r is the distance of point from the center of Earth, which is R by 2 here. So solving it, we will get V equals minus GME upon 2RE cube 3RE square minus R, that is R by 2. So RE square by 4. After solving, we will get the value of V as minus 11 GME upon 8 RE. We know GM equals GR square. Then putting the value of GME as G, small g, RE square, we will get the V as minus 11 by 8 small g RE. Now V we have calculated. The gravitational potential energy will be what? Minus 11 mg RE divided by 8. So this is the final expression we are having. Option number 4 is perfectly matching. We'll go with it. Move on to the next, that is 18 number. So here is question number 18, everyone. The energy of system at time t is given by Et equals a square e to the power minus bt, where b equals 0.1 per second. If error in the measurement of capital A and T are 0.75% and 1% respectively, then the maximum percentage error in the value of Et at t equal to 4 seconds will be what? Alright, E is given as a square e to the power minus bt. Taking log both sides, we have ln E equals ln a square plus ln e to the power minus bt. This is property of log xy equals log x plus log y. Now one more step, ln e equals, this will comes out 2 times ln a, this will also comes out minus bt ln e. Taking natural log of exponent gets you always 1. So equation becomes ln e equals 2 times ln a minus bt. Differentiating both sides, we will get delta e upon e equals 2 times delta a upon a minus b times delta t. Now relative error in E, relative error in A, if multiply and divided by t both sides, relative error in t. But we have to calculate the maximum percentage error. Let us multiply by 100 both sides. What we will get? Percentage error in E equals 2 times percentage error in A. Maximum percentage error, so we need to put plus sign here. B into percentage error in T multiplied by T. So here percentage error in E will be 2 into A, that is 0.75%, plus B 0.1 multiplied by T, 1 multiplied by time T, that is 4 seconds. After solving this, we will have the percentage error in E, that is 1.9%. So we will go with option number 1. Now move on to the next, that is 19 number. Now here we have question number 19, everyone. In the given circuit, the potential difference between point A and B will be, consider diodes are ideal. If diodes are ideal, then in forward bias condition they will act short circuited, and reverse bias condition they will act open circuited. The condition is reverse bias because N terminal is connected at higher potential. So reverse biased condition, diode open circuited. Circuit is now become 10 kilo ohm, 10 kilo ohm. Points are A, B. We have to calculate VA minus VB. 60 volt. Let us calculate the electric current first. The total current I will be given by total resistance and EMF, that is 60 upon 20 into 10 to the power 3. Solving gets you 3 into 10 to the power minus 3 ampere. This is the value of current flowing. Now the potential difference between these 2 points will be what? VA minus VB given by I into this resistance, that is 3 into 10 to the power minus 3 multiplied by 10 into 10 to the power 3 volt. 30 volt will be our answer. Option number 2 is perfectly matching. We will go with option number 2 only. Move on to the next, that is 20 number. Question number 20, everyone. In the circuit shown in figure, when the input voltage to the base resistance is 20 volt and VBE is 0, then value of base current will be what? Here is VBE, that is 0 in the question. Now let's apply the Kirchhoff's voltage law through this path. We have VI minus IBRB equals 0. From here the value of IB we can have VI divided by RB. So IB will be VI, that is 20, divided by RB 200 into 10 to the power 3 ampere. Further solving gets you IB as 0.1 milliampere. Option number 4 truly correct. Move on to the next, that is 21 number.